this lecture we will be discussing about the multi-server queuing model, which means M bar S and this first in first out model. So this multi-server problem we are going to do in this particular lecture. So in multi-server model, first of all we need to find out the arrival rate, that is same as that of a single server model itself. Average number of arrivals per hour. Service rate is given by mu. So arrival rate is equal to lambda and service rate is equal to mu, and number of servers is represented by either S or C. The utilization factor is given by the equation rho is equal to lambda by C into mu. If this value is less than 1, we can say that the system is stable. Now we need to find out P0. P0 represents there is no person in the system, that is system is idle or the server is free. So to find out, the equation is as shown here, 1 divided by sigma n is equal to 0 to c minus 1 lambda by mu all raised to n divided by n factorial. So this is a one term which is actually summation. For example, if we have 3 servers, then n is equal to 0 to 3 minus 1, 2. So we have to put that values, lambda by mu all raised to 0 by 0 factorial plus lambda by mu all raised to 1 divided by 1 factorial, then lambda by mu all raised to 2 divided by 2 factorial. So this will constitute this particular component. Then plus the other component, that is lambda by mu all raised to c divided by c factorial into c mu divided by c mu minus lambda. So this particular equation is very much important because for all the parameters to find out, we need this value. So you need to study this particular equation first. So I will write it once again and we will see. So P0 is equal to 1 divided by sigma n is equal to 0 to c minus 1 lambda by mu all raised to n divided by n factorial. So this is the first term plus lambda by mu all raised to c divided by c factorial into c mu divided by c mu minus lambda. So this is the second term. This is second term and this is the first term. So solving this will give you the value for P0. Now looking at the parameters, the first one is the length of the system, that is average number of people in the system or expected number of people in the system, that is given by LS, which is equal to the formula lambda into mu into lambda by mu all raised to c number of servers divided by c minus 1 factorial into c mu minus lambda square P0 plus lambda by mu. So this is the equation for LS. Actually, if you study at least this equation, the P0 equation and LS, we can actually determine all the remaining parameters. So I will show you how. So LS is equal to, the formula is lambda into mu into lambda by mu all raised to c divided by c minus 1 factorial into c mu minus lambda the whole square into P0 plus lambda by mu. So already we have studied the equation for P0. Now if you have studied this particular equation, LS is equal to lambda into mu into lambda by mu all raised to c divided by c minus 1 factorial into c mu minus lambda the whole square into P0 plus lambda by mu. If it is clear, then we can find out from here itself Ws. Ws is equal to Ls divided by lambda, because we know that lambda is equal to Ls into Ws as per the Little's law. from here the lambda has to be removed. From here two terms are there. Removing this 2, WS is equal to, we have to just remove. For example, I am writing here itself, LS divided by lambda will give you WS. So I am taking this lambda and this lambda, then it will become 1 by mu, and this is now become WS. Okay, so easily we can write WS. Now to write LQ, LQ basically means length of the queue. That is given by the equation LS minus lambda by mu. So we know the equation for LS, that is LS is equal to lambda mu into lambda by, that is equation. From that we have to remove the lambda by mu term. So removing this particular term will give you LQ. So this is LQ expression. Once LQ is with us, we can easily find out WQ, that is LQ divided by lambda. So we can remove this particular lambda and we can get the expression for WQ. So by studying one expression LS, we have find out LQ, WS and WQ. So that will make things more easier for you. Okay. So in the given materials, the LS expression is given, LQ expression is given, WS expression is over here, and WQ is over there. So total we need P0 equation, then equation for 4 main parameters, and the traffic intensity is given by lambda by C into mu. Okay. And one more equation, that is the probability that a customer has to wait, that is given by probability of n greater than or equal to C is given by the equation. Actually same equation, the only difference is, look at the values, the WQ, the equation is somewhat same with this equation. The only difference is that we don't have to square this C mu minus lambda. Here it was, square was there, in this case the square is not required. So studying the major component we can find out all the equations, okay, that you have to study. Now we will see some of the problems. So first simple problems, like if we may ask, like write a Kendall code for a multi-server queue with the Poisson distribution, exponential service and S identical servers, infinite capacity and FIFO discipline. So this represents the arrival distribution, this second term represents exponential, that is service distribution, number of servers, service discipline, capacity of the system and the population of the system. Okay. Now what is the stability condition? Stability condition means rho should be less than 1, system is stable. The rho is found out by lambda by S mu or lambda by C mu. Okay. Another question is that it is given that for an m bar 1 with lambda is equal to 9 and mu is equal to 4 and S is equal to 3, compute the traffic intensity rho. Actually here it should have been like 3, wrongly mentioned here. So the traffic intensity is given by rho is equal to 9 divided by 3 into 4, that is 9 by 12, which is actually 0.75. We can say that system is stable. Now look at another question. If lambda is 18 per hour and WQ is 5 minutes, compute the length of the queue. So length of the queue we can actually easily find out LQ, lambda into WQ, because this is little slow. Here lambda is in 18 per hour and WQ is in minute. So we have to convert that into hour. 18 into 5 by 60. Solving that we will be giving you 1.5. 18 by 12, that is 3 by 2 is equal to 1.5. So this is how the questions will work out. Now we will see a bigger picture. The question is that we have a tax consulting firm which has 3 counters in its office, so to receive people who have problems concerning their income, wealth and sales taxes. So the takeaway is that the C is equal to 3, and they are saying on an average 48% arrive in an 8-hour day. So from that we have to find out lambda. So 48% in 8-hour day means 48 divided by 8, that will give you number of hours people coming in an hour, that is equal to 6 persons per hour. So we find out lambda from that. Now we have find out the service rate. So here it is given that mu is means each tax advisor spends 15 minutes on an average on an arrival. So that means tax server is actually spending 15 minutes. That means the mu is equal to 60. Total we have 60 minutes in an hour, in which 15 minutes for each customer, that is 4 customers per hour. So we have find out mu also. Now we need to find out the values for the following items. Average number of customers in the system. So average number is actually represented by L, and here it is asked for system, that is LS. The average number of customers waiting to be served. The answer is waiting, that means LQ. Average time, they are asking for the time, that means it is WS. Here it is waiting time for a customer, that is WQ, because the early question was average time a customer spends in the system. Next one is the number of hours each week a tax advisor spends, and last one is the probability that a customer has to wait before he gets service, that is P of n greater than equal to 0. So this much parameters we have to find out. For that we have to apply the equations. Let's see. So as I mentioned, C is equal to 3 counters, 6 persons per hour, service rate is 4 persons per hour. Now let's see whether the system is stable or not. So rho is equal to, so lambda by C into mu. Here the lambda is 6 divided by 3 counters into mu is equal to 4. That is 6 by 12, which is less than 1. System is stable. So that's done. Now we can find out LS, LQ, WS and WQ. For that, first of all we need to find out P0. So from here we can find out the equation. So as I told, this is the first term, 1 divided by lambda by mu, that is 6 by 4. So 6 by 4 raised to n is equal to 0 in the first case. 0 divided by 0 factor, it is actually 1. So that is this 1. Then 6 by 4, that is 3 by 2. So 3 by 2 raised to 1 divided by 1 factorial, that is 3 by 2, plus 3 by 2 the whole square divided by 2 factorial is equal to 9 by 4 into 2 factorial, that is 9 by 8. So this is how that first term is coming. Okay. The second term, that is lambda by mu, that is 3 by 2, because 6 divided by 4, that is 3 by 2. So 3 by 2 the whole raised to C. C is actually 3. So 3 divided by 3 factorial is equal to 3 cube is equal to 27. 27 divided by 2 raised to cube is equal to 8 into 3 factorial means 1 into 2 into 3, that is 6 is equal to 27 by 48. So this is how this particular value comes. Into C is equal to 3, mu is equal to 4, that is 12 divided by 12 minus lambda is equal to 6. So this term. From that we found out the P0 is equal to 0.21. Once it is ready, then we can substitute in the LS equation. So LS is equal to lambda. The lambda value is equal to, it was 6 into mu, we know that it is, what is the value of mu? Mu is actually 4. So 4 into lambda by mu, that is 3 by 2 raised to C is equal to 3 divided by 3 minus 1, 2 factorial into C mu, that is equal to 3 into 4, 12, 12 minus 6 the whole square into P0 plus lambda by mu. So solving that will give you the value as 1.74 persons, because length of system is number of persons. Once LS is ready, we can easily calculate LQ. How? LQ is equal to LS minus lambda by mu, that is 1.74 minus lambda by mu is equal to 3 by 2, 1.5, that is 0.24 persons. So WS also we can easily find. How? LS divided by lambda will give you WS. WQ is equal to LQ by lambda. So that we can easily find out. Now the next question was the number of hours each week a tax advisor spends performing his job. That we need to find out the row first. the rho is equal to lambda by C into mu, that is 6 divided by 3 into 4, that is equal to 6 by 12 is equal to 0.5. So that means in a day they are actually they are engaged for 0.5 percentage. Each hour it's actually 4 hours, that is 8 into 0.5, 4 hours a particular tax advisor is spending. So 5 days, if you are considering that 5 into 4, 20 hours. So average a tax advisor spends around 20 hours in a particular week. If the raw value is 0.5, that is 50 percentage, total working hours into that value will give you the exact number. Then the next question was probability that a customer has to wait. For that, the equation is equal to mu into lambda by mu all raised to c divided by c minus 1 factorial to c mu minus lambda. So substituting that, we will get the value as 0.236. So this is how that particular problem is solved. So here the question was very direct. From that we find out lambda, then mu, then we find out p0, then determine all the parameters like ls, lq, ws, wq and etc. So it's a direct question. So we need to know how to substitute these values in the equations and solve. So practice that. Okay. So moving on to another problem, that is ships arrives at the port at a rate of 1 in every 4 hours. That means in 4 hours one ship is coming. So the arrival rate, number of ships coming per hour is 1 by 4. So lambda is equal to 1 by 4 ships per hour. The time a ship occurs at berth for unloading as exponential distribution with an average of 10 hours. So that means for unloading, that is a service. For that service they take an average of 10 hours. That means 10 hours they will take to unload one ship. So mu is equal to 1 by 10. So mu is equal to 1 by 10. Okay. Now here the question is if the average delay of ships waiting for the berth is to be kept below 14 hours. So they are asking for the average delay of ships waiting. That means the average waiting time, that is WQ, has to be less than 14 hours. In that case, how many berths should be provided at the seaport? That means they are asking for the value C. So for that, the first thing lambda, mu, then we need to see to find out C. For that, rho is equal to lambda by C into mu, which has to be less than 1. The lambda we got it as 1 by 4 divided by 1 by 10 in the case of mu, which has to be into C into 1 by 10, because we will see it should be less than 1. So solving this, we will get it as, so solving this we will give you 10 by 4 C is less than 1, that is 5 by 2 C less than 1. That means the C has to be greater than 5 by 2, that is C should be greater than 2.5. So since it's a berth, we need a whole number. So C has to be, first we will check with 3. So substituting C as 3, we will determine the value of WQ. For that, the equation is mu into lambda by mu over C by into C minus 1 factorial C mu minus lambda the whole square by P into P0. So we need to find out P0 first. So the P0 is given by the equation. So solving that, we will give you P0 as 0.045, and substituting this value we will get the WQ is equal to 14.06. But the requirement was it has to be less than 14 hours. So we will recalculate for C is equal to 4. So substituting that C is equal to 4. This is regarding the calculation of C is equal to 3. Now we are doing it for C is equal to 4. We got the value as WQ is equal to 13.7, which is less than the specified 14 hours. Hence we need 4 berths should be provided at the port. So I repeat, ഇത് ചെയ്തത്രേ ഉള്ളൂ. നമ്മൾ ഫസ്റ്റ് ലാംഡായും മ്യൂവും കണ്ടുപിടിച്ചു. നമ്മുടെ അടുത്ത് ചോദിച്ചിരിക്കുന്നത് 14 hours വെയിറ്റിംഗ് ടൈമിൽ താഴെ നിർത്തണമെങ്കിൽ എത്ര ബർത്ത് വേണമെന്നാണ്. അപ്പോൾ നമുക്കറിയാം സിസ്റ്റം സ്റ്റേബിൾ ആവണമെങ്കിൽ ദ ലാംഡ ബൈ സി മ്യൂ എന്ന് പറയുന്ന വാല്യൂ <1 ആയിരിക്കണം. അത് പ്രകാരം നമുക്ക് കിട്ടി സി എന്ന് പറയുന്നത് >2.5 ആയേ പറ്റുള്ളൂ. സോ വി സ്റ്റാർട്ട് വിത്ത് 3. അത് ട്രയൽ ആൻഡ് എറർ ആണ്. സോ സി നമ്മൾ 3 വെച്ച് സ്റ്റാർട്ട് ചെയ്തു. 3 സ്റ്റാർട്ട് ചെയ്ത് കഴിഞ്ഞപ്പോൾ നമ്മൾ എന്ത് ചെയ്തു, അത് വെച്ച് WQ കണ്ടുപിടിച്ചു. WQ വേണമെങ്കിൽ നമുക്ക് P0 വേണം. സോ P0 ആദ്യം കണ്ടുപിടിച്ചതിന് ശേഷം WQ കണ്ടുപിടിച്ചു. WQ കണ്ടുപിടിച്ചപ്പോൾ നമുക്ക് കിട്ടി അതിൻ്റെ വാല്യൂ 14.06 എന്ന് കിട്ടി. അത് പക്ഷേ നമ്മുടെ റിക്വയർമെൻറ്റിനെക്കാട്ടും കൂടുതലായതുകൊണ്ട് നമ്മൾ 4 കാൽക്കുലേറ്റ് ചെയ്തു. സോ 4 കാൽക്കുലേറ്റ് ചെയ്തപ്പോൾ നമുക്ക് കിട്ടി 4 ബർത്തുകൾ, അതായത് WQ <14 hours വന്നു. സോ 4 ബർത്ത്. സോ ദിസ് ഇസ് ഹൗ ദ പ്രോബ്ലം ഹാസ് ബീൻ സോൾവ്. Now moving on to another question. Library wants to improve its service facility in terms of waiting times for borrowers. The library has 2 counters, so C is equal to 2 and with arrival rate 1 in every 6 minutes. That means 60 divided by 6 is equal to 10 persons are coming per hour, and the service time is equal to 10 mean of 10. That means mu is equal to 10 per hour. So considering these two things, the raw value is equal to 10 divided by C is equal to 2 into 10, that is 10 by 20, which is less than 1. Okay. Now the question is, the library has relaxed its membership rules and substantial increase in number of borrowers expected. So they are actually relaxed the rules. So we need to find number of additional counters to be provided if the arrival rate is expected to twice the present value, and the average waiting time of the borrowers must be limited to half the present value. So here also the WQ has to be determined because it has to be half the present value. So first of all we need to find that present waiting time using lambda is equal to 10, C is equal to 2 and mu is equal to 20. Mu is equal to 6. Mu is equal to 6. We need to find out the WQ. So let's see. So as I mentioned, 10 borrowers per hour, 6 borrowers, 2, the value is less than 1. First calculate the WQ for C is equal to 2. For that first find P0, then WQ. We have got the values and this is how this thing works, and WQ is equal to 0.379 hours. So our requirement is the average waiting time has to be limited to half the present value. So 0.37 divided by 2 has to be less than the new one. For ഇനി നമ്മൾ കണ്ടുപിടിക്കുന്ന WQ എന്ന് പറയുന്നത് it should be half this particular value. Okay. For that we substitute C is equal to 3 first. When C is equal to 3, what happens? 3 substitute ചെയ്തു. Here the problem is lambda എന്ന് പറയുന്നത് 20 ആയിട്ട് കൂടി എന്ന് പറയുന്നുണ്ട്, ഇരട്ടി ആയെന്ന് പറയുന്നുണ്ട്. So lambda is equal to 20. So 20 divided by 3 into 6 is equal to 20 by 18, which is actually greater than 1. So നമുക്ക് C3 എടുത്തു കഴിഞ്ഞാൽ സിസ്റ്റം എക്സ്പ്ലോഡ് ആയി പോകും. അപ്പോൾ അവിടെ നമ്മൾ കൗണ്ട് ചെയ്യേണ്ട കാര്യമില്ല. അതുകൊണ്ട് we'll start with C is equal to 4. C4 ആകുമ്പോൾ റോ വാല്യൂ ലെസ് ദാൻ 1 ആണ്, 20 divided by 4 into 6. അതുകൊണ്ടാണ് നമ്മൾ C4 ആക്കിക്കൊണ്ട് എന്ത് ചെയ്യുന്നു, we will find out the P0, then we will find out the WQ. So WQ കണ്ടുപിടിച്ച് നമുക്ക് കിട്ടി 0.164 ആണ്. സോ WQ 0.164 ആണ്. അത് ഹാഫ് വാല്യൂ 0.379 കാട്ടി ഹാഫ് വാല്യൂവിലാണ്. ഹെൻസ് വി ക്യാൻ സേ ദാറ്റ് 2 അഡീഷണൽ കൗണ്ടേഴ്സ് വേണമെന്ന് പറയാം. അപ്പോൾ നമ്മളിവിടെ ചെയ്ത ക്വസ്റ്റ്യൻ വായിച്ച് നോക്കുകയാണെങ്കിൽ നമുക്ക് ക്ലിയർ ആണ്. ആദ്യം ഒരു ലാംഡയും മ്യൂവും തന്നിരുന്നു, അത് വെച്ചുകൊണ്ട് നമ്മളൊരു അതിൻ്റെ വെയിറ്റിംഗ് ടൈം കണ്ടുപിടിച്ചു. എന്നിട്ട് അവർ പറഞ്ഞു ഈ ലാംഡ വാല്യൂ എന്ന് പറയുന്നത് ഇരട്ടി ആവുകയാണ്, അങ്ങനെയാണെങ്കിൽ എത്ര കൗണ്ടേഴ്സ് അഡീഷണൽ വേണമെന്ന് പറഞ്ഞു. അതിനുശേഷം അവർ പറഞ്ഞ റിക്വയർമെൻറ്റ് നമ്മൾ എന്ത് ചെയ്തു, നമ്മൾ വീണ്ടും അത് കാൽക്കുലേറ്റ് ചെയ്തു. ആ കാൽക്കുലേറ്റ് ചെയ്തപ്പോൾ നമുക്ക് കാണാൻ പറ്റി C is equal to 4 വരുന്ന കേസിലാണ് വാല്യൂ ഹാഫ് ദ പ്രസൻറ്റ് വാല്യൂ ആയത്. അപ്പോൾ അത്രയും അഡീഷണൽ കൗണ്ടേഴ്സ് വേണം. അതായത് ആദ്യം ഉണ്ടായിരുന്ന 2, അതിൻ്റെ കൂടെ 2 കൂടെ ആഡ് ചെയ്ത 4 ആകുന്നത്. സോ ദിസ് ഇസ് ഹൗ ദിസ് പ്രോബ്ലം ഈസ് സോൾവ്. ഓക്കെ. സോ അടുത്തൊരു ക്വസ്റ്റ്യൻ ആണ്. ക്വസ്റ്റ്യൻ വായിക്കുക. ബാങ്ക് ഹാസ് 2 ടെല്ലേഴ്സ് ഉണ്ട്. അപ്പം C is equal to 2 ആണ്. The first teller handles withdrawals only while the second teller handles deposits only. സോ ഇവർ പറഞ്ഞിരിക്കുന്നത് ഇപ്പോഴത്തെ കറണ്ട് കണ്ടീഷനിലുള്ള ഓരോ കസ്റ്റമേഴ്സിൻ്റെ സർവീസ് ടൈമും എല്ലാം അവർ പറഞ്ഞിട്ടുണ്ട്. അതായത് സർവീസ് ടൈം 3 minutes per കസ്റ്റമർ ആണ്. ഡിപ്പോസിറ്റേഴ്സ് വരുന്നതിൻ്റെ റേഞ്ച് പറഞ്ഞിട്ടുണ്ട് 16 hours. ഒന്ന് വിഡ്രോവൽസ് വരുന്നത് റിക്വയർമെൻറ്റ് 14 പെർ അവർ ആണ്. അപ്പോൾ 2 ലാംഡ വാല്യൂസ് ഉണ്ട്, ലാംഡ 1ഉം ലാംഡ 2ഉം, ഒരെണ്ണം 16ഉം ഒരെണ്ണം 14ഉമാണ്. അപ്പോൾ ഇവിടെ ചോദ്യം എന്താണെന്ന് ചോദിച്ചു കഴിഞ്ഞാൽ, എന്താണ് ഈ 2 ഡിപ്പോസിറ്റേഴ്സിനെയും വിഡ്രോവേഴ്സിനെയും ഒരാൾ തന്നെ ഹാൻഡിൽ ചെയ്താൽ എന്ന് പറഞ്ഞാൽ ഈ അറൈവൽ റേറ്റ് കമ്പൈൻ ചെയ്യുക. അപ്പോൾ പുതിയൊരു അറൈവൽ റേറ്റ് കിട്ടി, ലാംഡ ഇസിക്കൽ ടു 30 പെർ അവർ. അങ്ങനെ കിട്ടിക്കഴിഞ്ഞാൽ എന്താണ് എഫക്റ്റ്? ഓക്കെ, അപ്പം മ്യൂ വാല്യൂ തന്നിട്ടുണ്ട്, ലാംഡ വാല്യൂ കിട്ടി, നമുക്ക് എന്ത് ചെയ്താൽ മതി? എഫക്റ്റാണ് വെയിറ്റിംഗ് ടൈമിനുണ്ട്. അപ്പോൾ WQ കണ്ടുപിടിക്കുക. രണ്ടാമത് ചോദിച്ചിരിക്കുന്നത്, ഇനി സർവീസ് ടൈം 3 എന്നുള്ള 3.5 ആയിക്കഴിഞ്ഞാൽ എന്താണ് വെയിറ്റിംഗ് ടൈമിൽ സംഭവിക്കുക? അപ്പോൾ അതെങ്ങനെ ചെയ്യുന്ന നോക്കിയേ. ഫസ്റ്റ് അറൈവൽ റേറ്റ് കാര്യം തന്നിട്ടുണ്ട്, അതിൽ നിന്ന് 3 മന്ത്സ് മ്യൂ കണ്ടുപിടിച്ചിട്ടുണ്ട്. അറൈവൽ റേറ്റ് കമ്പൈൻഡ് ആകുമ്പോൾ നമ്മൾ ആദ്യം 30, അപ്പോൾ നമുക്ക് കിട്ടുന്ന വാല്യൂ എന്ന് പറയുന്നത് ലാംഡ എന്ന് പറയുന്നത് 30 ആണ്, ഡിവൈഡ് ബൈ 2 × 20, ദാറ്റ് ഈസ് 30/40 ഇസിക്കൽ ടു ലെസ് ദാൻ 0.1 ആണ്. സോ അത് വെച്ചുകൊണ്ട് നമ്മൾ എന്ത് ചെയ്തു? WQ കണ്ടുപിടിച്ചു. WQ നമുക്ക് കിട്ടി 9/140 hours. വേണമെങ്കിൽ മിനിറ്റ്സിലേക്ക് കൺവേർട്ട് ചെയ്യാം, കൺവേർട്ട് ചെയ്യാൻ 3.86 എന്ന് കിട്ടി. ഇനി അവർ പറഞ്ഞിരിക്കുന്നത് നമുക്ക് വേണ്ടത് അടുത്ത കേസിൽ നമ്മൾ സർവീസ് ടൈം 3.5 മിനിറ്റ്സ് ആക്കി. സർവീസ് ടൈം 3.5 എന്ന് പറഞ്ഞു കഴിഞ്ഞാൽ 60 ഡിവൈഡ് ബൈ 3.5 ദാറ്റ് ഈസ് 120/7 കസ്റ്റമേഴ്സ് പെർ അവർ ആണ്. അപ്പോൾ ആ വാല്യൂ സബ്സ്റ്റിറ്റ്യൂട്ട് ചെയ്ത് നമ്മൾ എന്ത് ചെയ്തു? WQ കണ്ടുപിടിച്ചു. അപ്പോൾ നമുക്ക് 11.43 കിട്ടി. അപ്പോൾ എഫക്റ്റ് ആയിട്ടും ബെറ്റർ ഏതാ? അതായത് 2 വിഡ്രോവൽസിൻ്റെയും ഡെപ്പോസിറ്റേഴ്സിൻ്റെയും ഒരുമിച്ച് നമ്മൾ അഡ്രസ്സ് ചെയ്ത് കഴിഞ്ഞാൽ വെയിറ്റിംഗ് ടൈം എന്ന് പറയുന്നത് ബെറ്റർ ആണ് വെൻ കമ്പയർഡ് ടു ദ സർവീസ് ടൈം ഇൻക്രീസ് ആവുമെന്നുള്ള കേസ് വെച്ച് നോക്കുമ്പോൾ. സോ ദിസ് ഈസ് ഹൗ ദ പ്രോബ്ലംസ് ആർ സോൾവ്. അപ്പോൾ ഇത്രയും ഹാൻഡിൽ ചെയ്ത് കഴിഞ്ഞാൽ മൾട്ടി സെർവറിൻ്റെ കുറച്ച് പ്രോബ്ലംസ് നിങ്ങൾക്ക് പഠിക്കാൻ പറ്റും. അപ്പോൾ P0യുടെ ഇക്വേഷൻ പഠിക്കുക, അതിനുശേഷം അതിൽ നിന്ന് LS പഠിക്കുക, ആ LSൽ നിന്ന് തന്നെ ബാക്കി എല്ലാം ഡിറൈവ് ചെയ്യാൻ പറ്റും. അതുപോലെ തന്നെ P(n) > C എന്ന ഇക്വേഷൻ പഠിച്ചു കഴിഞ്ഞാൽ ഈസി ആയിട്ട് മൾട്ടി സെർവറിൻ്റെ പ്രോബ്ലംസ് ചെയ്യാൻ പറ്റും. ഓക്കെ, താങ്ക് യു.